In this section, we will go over the various components of the total station. Set the case on the ground with the manufacturer's label up. Pull the two latches out and up and open the case lid. Here you can see the instrument, the manual, battery, and the rain covers for the instrument and the objective lens. Lift the instrument by the handle. This is the only way you should carry it. Open the battery compartment by turning the block knob to the horizontal position. Press inward on the two latches and pull the battery cover off. Maintain the correct upward orientation of the cover. It can only go on one way. The battery is inserted into the cover so that the contacts match the contacts in the compartment. You should note the serial and model numbers before you close the battery compartment. Ensure you turn the knob to the locked position after reinserting the battery. The instrument is mounted onto the tripod by a hollow screw that threads into here. You can find the power button on the side of the instrument. Press it in and hold for 2 seconds to turn it on and also to turn it off. When it comes time to look through the instrument, you will need to focus the targeting crosshairs. When focused, they should look like this or this, depending on the instrument orientation. The vertical crosshair has two parallel lines used to help obtain the best focus. Focus of the crosshair is dependent on your eye. Focus with one eye and know that focus will not necessarily be the same for your other eye or any other person. For this reason, only one person should do the sighting at any one station. The crosshairs are focused by looking through the lens and turning the smaller of the two knobs clockwise or counterclockwise until the two parallel vertical crosshairs are separate and sharply focused. Do not adjust the focus again until after the measurement is complete. The instrument telescope is focused by the outer ring. While looking at your target, turn the ring to focus it. The instrument is menu driven and all functions are displayed on this data screen. There are soft touch keys along the bottom and side of the screen. They change functions depending on which menu screen you are on. There is also an alphanumeric keypad to the right of the screen. The objective lens of the instrument is here. This is where the ranging laser is located. Don't look into the lens while the laser is being fired. The instrument also has a laser plumb and is shot through the threaded insert on the bottom of the instrument. Don't look directly into this laser either. The instrument is capable of measuring azimuth and bearing down to 1 second of arc. Your manual dexterity is not sufficient for this precision, so horizontal and vertical control knobs are provided for the necessary fine adjustments. The instrument has a very narrow field of view through the telescope, so in order to align the instrument onto the target, an optical sight is provided on the top. With both eyes open, sight the target and turn the instrument by hand. The sight is opaque, so you will not be able to see through it, but with both eyes open you will be able to see a crosshair hanging in space. Move the instrument manually to align the instrument to the target. There are two fish eye bubble levels on the instrument, an upper and a lower. Each has a different purpose, and the correct one must be used when called for in the lab instructions. The instrument is level when the bubble is centered in the inner ring of the level. On the tribrac of the instrument there are 3 foot screws. These are used to do the fine leveling of the instrument. The lab instruction sheet will tell you when and how to adjust these foot screws. You should know that they should be turned slowly and delicately when using them, as it is very easy to overshoot the level point with quick or coarse adjustments. It is best to start the lab with the foot screws roughly centered in their stroke. Rotate the foot screws until the tops align with the midpoint marking ring. When setting up the instrument, you will need to enter its height. The height is measured while the instrument is set up over the station point, from this indent in the side to the ground. Measuring both sides to the ground and taking the average will allow you to account for topography the tripod is set on and enter the true instrument height over the point. In this section, we will go over the various parts of the tripod and how to set it up. The tripod has a carrying strap, and also another that holds the legs together. First, we will unlatch the strap that holds the legs together. Set the tripod with a relatively wide stance for stability. Each leg is extendable. The legs collapse into themselves and are locked at the proper extension with these locking screws. Whenever possible, the feet of the tripod should be pushed into the ground for stability. Next, you can remove the cap from the tripod. It is attached by a captured screw that is threaded into the bottom of the cap. In this section, we will discuss the reflector. The reflector is part of the system that defines the point that will be measured, and does so by being a target for the instrument and reflecting the ranging laser from the total station back to it. The aluminum pole that the reflector is mounted to is height adjustable. This allows it to be more easily used as a target when topography interferes. The endpoint of the pole defines the target. To precisely define the target, however, the reflector must be vertically centered over the point being measured. For this, there is a bubble level mounted on the pole. The pole is vertical when the bubble is centered in the ring of the level. Take a stable stance with both hands on the pole and your feet apart, comfortably but firmly on the ground. Lock your elbows to your body and bring the bubble to level. The reflector is a 6-element prism that reflects light back to the exact point of origin of the light. The prism is on a swivel. This allows you to adjust it to take into account any differences in height between the prism and the instrument. Ensure the prism points back to the instrument. There is a sight to help you if needed. In order to be accurate, the center of the prism needs to be targeted by the total station. The 3 triangles on the reflector are used to help locate the center. You will need to measure the height of the reflector to enter the data into the instrument. The height is measured at these indented points on the reflector.